welcome to the second EFG webinar on minerals of the year. I am Markku Iljina, the current coordinator of the EFG Panel of Experts on minerals. The mission of this panel is to sustain and enhance EFG voice, professional voice in minerals concerning international collaboration. Please visit the EFG website and navigate yourself to the Panel of Experts page, and you can read more. And we are, of course, expecting applications of new members to join in. So please contact, and if you wish to join into the Panel of Experts on minerals. Today, Magnus Johansson will be presenting the webinar Mineral Resources of Sweden. Magnus is chair of Geosektionen, the geoscientist branch of the Swedish Association of Professional Scientists, Naturvetarna in Swedish. He is also a member of the EFG Panel of Experts on Minerals. Magnus has spent more than 10 years in mining and mineral sector and has wide experience from other areas, totaling some 15 plus years. He has worked in different positions ranging from research, applied geology, and consulting to state agency physical planning roles, and recently founded a private consultant company. And after Magnus' presentation, we will have a short question and answering session of 10 minutes approximately. We invite you to send your questions using the question and answering function, which you can find in your Zoom application. And we will select some of these questions to be answered. And I just note that please send your questions using this question and answering function and not the chat channel. So Magnus, please start when you are ready. So the floor is yours.
Thank you very much. So I wish to thank the European Federation of Geologists for the invitation to talk here in the EFG Mineral Webinar series, and I also thank the host Markku Iljina for the kind introduction. Since the Middle Ages, Sweden is well known among others for mining and iron. Today, mining of traditional ores and mineral resources is still quite strong in Sweden, but there are new potentials emerging. What is the first thing you'd think about when you hear about Swedish steel? Perhaps the town of Kiruna, where you produce a lot of iron ore. In Germany, the term generally refers to high quality steel. If you are German speaking, you might also think about a special kind of steel furnishing item. And for the non-Germans, to be put behind Swedish curtains, that's the slang for ending up behind steel bars. In 2019 was an all-time high for the Swedish iron ore production, a total of near 40 million tons of iron ore and close to 50 million tons of non-ferrous ores were mined. After processing, the production resulted in roughly 27 million tons of iron and about 1 million tons of non-ferrous ores. If you know your math, you notice that Swedish iron ore is quite high grade, but still Sweden is a small global player, as you'll see on the picture, in comparison to other producers like Brazil or Australia. Sweden, though, accounts for more than 90% of the European iron production and contributes a considerable amount to the EU base metals, silver and gold production. Despite this, Swedish mineral resources have yet much more to offer, especially if you look for technology critical minerals, TCE. So in the talk, I'm going to go through the geologic setting of Sweden, the mining sector, the mineral resources available, and an outlook on the future potential. I'll also discuss a few examples on recent exploration projects or mining application projects for TCEs. The geologic setting of Sweden differs from Central Europe. In brown and red, we have the Proterozoic and Archean ancient basement rocks of the Fennoscandian Shield. That's a tectonic plate creating similar geologic settings on both sides of the northern Baltic. We're talking about quite old crystalline bedrock, mostly formed some 1.8 to 2.5 billion years ago. These rocks are remnants of the Sweco-Karelian orogeny, sometimes also called the Sweco-Fenian. This Paleoproterozoic basement hosts well-known regions of massive historic mining, as well as the Swedish mines currently in operation. And this geological unit confines a large part of ongoing prospecting works as well. In lighter color, the younger Sweco-Norwegian orogeny, 0.9 till 1.1 billion years old, crystalline basement, granites showing, and this area also shows remnants of subduction zone. In this area, mining mostly consists of small-scale historic operations, for example, on silver or sulfide ores, but further potential for precious and base metal mining is evaluated. Together, the Sweco-Karelian and the Sweco-Norwegian geological regions form the basement rocks of the Fennoscandian Shield and together comprise near 80% of Swedish territory. In light blue, we have the Phanerozoic sedimentary cover rocks deposited on top of this ancient crust, making out most of the southern part of the map. It's Ordovician to Tertiary age autochthon deposits that stretch across the southern Baltic. These sedimentary layers with igneous parts once covered large parts of Sweden, but today comprises only 4% of the Swedish territory. We have volcanics, sandstone, shale, limestone, all that you know very well in Central Europe. This geological setting contains areas of historic coal and clay mining for Sweden, active limestone and dimension stone mining, but also promising prospects on critical raw materials and metals in the Ordovician alum shale, to which I will return later in the presentation. These patchy areas are erosional remnants that have been preserved in various ways. You've got the meteorite impact structure, such as the Siljan area of central Sweden. It has been preserved in table mountains under the protective cover of volcanic sills in Västergötland. You'll find it in areas protected by tectonic downfaulting in South Sweden, Scania area, as well in the topographic downs of the Baltic basin with the islands of Öland and Gotland representing these sedimentary layers. Last but not least, the early to mid-Paleozoic, that's Ordovician to Devonian, some 500 until 400 million years old Caledonian orogeny, comprising folded and thrusted nappes of crystalline and sedimentary rocks of Scandinavia. We also find them in Greenland. They build up the present-day Scandinavian mountain range and created as the Iapetus Ocean finally closed and Baltica collided with Laurentia. These rocks make out some 17% of Swedish territory, but are in large parts difficult to access. The Caledonian orogeny hosts the Grong-Stekenjokk mineral district, where currently a number of prospects on base metals and noble metals are active along the Swedish-Norwegian border. In addition, we have, of course, quaternary deposits covering virtually most of Scandinavia. Not very interesting for the ores, but providing means of tracking down interesting ore deposits through the chemical trace or chemical signature of the moraine. Mining started with iron ore, copper, base and noble metals, like in the rest of Europe, though a little bit later. Miners' knowledge and technology was imported from Central Europe, such as Rammelsberg in Germany, and technical terms adopted from the German language. Mining has, over time, had a huge impact on Swedish state finances, as well as Swedish industry and state-of-the-art technology development. Mining was the very base for Swedish empire ambitions also. In the European wars of the 17th and the 18th century, without the mining and the associated industry, Sweden and Swedish society would look quite very much different today. Sweden has some 3,000 registered historic mines. Surely a lot more that we do not know about. Blue dots here on the map refer to iron ore deposits. The red dots show non-ferrous ores. And from the map, it's quite obvious that the vast majority is located in central Sweden, a region called Bergslagen. The time scale here shows operation time for a selection of Swedish mines. You'll have blue and red colored lines show active iron ore and non-ferrous ore mines. Green and yellow lines show historic iron ore and non-ferrous ore mines. Several mines have been intermittently active, such as Svappavaara or Kaunisvaara, both iron ore. And you'll also notice that in the lower part, the green and yellow, that is the Bergslagen area where many mines have closed. Some well-known historic mines that I'll pick out. We've got the Falun mine of the province of Dalarna. It's a copper mine documented from the 12th century, mine closure in 1992, lastly producing sulfur. Its heyday was the 17th century, and in times Falun accounted for 2/3 of the world copper production back then. Besides copper and sulfur, also sulfide ores with zinc, lead, bismuth, silver, and gold have been mined. Byproduct is the Swedish Falu red paint, which is quite well known. Today, Falun copper mine is a UNESCO World Heritage Site. We've got the Garpenberg mine, documented from the 13th century. Garpenberg is, in spite of it, at least 700 years of documented continuous operation, still active, and today a part of the Boliden Group. It is a skarn sulfide ores deposit. Main commodity is zinc, but lead, copper, silver, and gold are also produced. We have the Sala silver mine. That's documented from the late 14th century. Very rich silver ore in a skarn setting. Heyday was the 16th century when up to 5 tons of silver was mined each year, financing the strive for a Swedish empire. Also lead and zinc was mined in periods. The mine closed in 1908, and today there is still operation, but only for dolomite, which is quarried at Sala. And that so many mines ended in this region of Bergslagen, that's partly a consequence of the steel crisis in the 70s. As for the Dannemora, Norberg, and other mines. In this map, you will have the large dots show location of the active Swedish mines of today. Iron is a blue signature, sulfide red, and noble metals yellow. So you'll see the iron is in the north. Sweden's mineral assets are primarily situated in the 5 main mineral districts. And we have Norrbotten in the very north. Iron and gold are the main and sulfide ore. You will have the Skellefteå field, Boliden area. You will have the Bergslagen area. And all currently active mines are within these 3 districts. Then we have 2 more. The so-called gold line near the Skellefteå field and the Grong Stekenjokk district of the Caledonites. That's the only mineral district outside the Sweco-Karelian area. And as you look at the map, you'll see small widespread dots that mark location of other known mineralizations. So we have these abundant provinces, but mineralizations on a wide scale throughout the country. The current state of the Swedish mining industry is 12 active mines as of today. LKAB is a state-owned iron ore company with 3 active mines in the north. Kiruna and Malmberget are well known. The Boliden concern is well known for its Aitik mine, as well as Garpenberg in the south, and several mines in the Boliden area, Skellefteå field. We have the Kaunis iron up in the northeast, where Kaunisvaara has started up again. Lundin mining is present in the very south at Zinkgruvan. And we also have another one in Bergslagen, Lovisa-gruvan, a small mine, but one of the active ones. And of course, in addition to this, there are inactive mine sites, closed down mines or temporarily closed down mines where ore is processed and enriched, such as Svartliden or Svappavaara. Sweden also has an industry cluster behind all these mines of internationally well-known mining equipment companies. And these mines are internationally competitive due to high ore grades on the one side, but a high level of automation and using the technology of the industrial clusters and industry behind it. Challenges for today are long permitting processes, social licensing, public awareness of the raw material needs. These are problems you find throughout Europe, every country on earth, I'd say. Of the registered Swedish mineral deposits by million tons of iron, base metals, noble metals, graphite, REEs, and further, all summed up. In dark orange, you'll see reserves. That's known mineralization that is profitable to mine. Of course, the distribution matches the previous image of the active mines, as if then you'll do the reserve counting. The resources, that's a known mineralization with reasonably high likelihood for economically viable production. Compared to the previous slide, you can see that there are large unexploited deposits. These are prospects and partly application processes for new mines in the pipe. And also one thing, if you think about dimensions and tonnage, if you look at the map, you should think about the commodity. Deposits such as REE and battery metals may be of much more importance than the size of the symbols or the tonnage indicate. Of course, iron ore is used on another quite another scale than REE elements. And looking on one of these REE prospects, or actually applied mines, is Norasia. That's a rare earth elements deposit. And here we have a TCE, a critical resource for technology metals. It's one of the world's principal heavy REE resources, and so far the only deposit of note within the EU that can compare. It has an unusual enrichment in the most critical REEs that are essential for high-strength permanent magnets, such as dysprosium, terbium, neodymium, and praseodymium. Norasia is per-alkaline, layered nepheline cyanide intrusive complex, and it dates some 1.5 billion years, belonging to the slightly older Fennoscandian part of the basement. Probable reserves by 20 years life of mine would be 23 megaton, indicated at 0.6% REE, total of 17 megatons waste rock, according to the calculations of the company. As a comparison, a wind power mill may need 350 kilos of neodymium and other REE each turbine. This day pit would measure some 900 by 400 meters and 150 meters deep. So it's a 25-hectare total area for the infrastructure. Enriching process is acid leaching, like Talvivaara in Finland, and this is also a concern for many. Most of you will remember the Talvivaara dam breach in 2012. 2013, a 25 years exploitation permit was granted, but reverted to application status by a Supreme Court verdict in 2016. So the project, it's back at the start again. The main concerns are Natura 2000 assessment, the tailings management, and water quality issues. You don't see it on the picture, but it's quite close to the Lake Vättern of Sweden, which is a drinking potable water or drinking water source for quite large regions in Sweden. And it's also a quite populated land, and there are many neighbors all around this project, of course. Some new discoveries. Of course, there are many ongoing prospects in Sweden. In recent years, new discoveries have been made at a number of places and are being evaluated. Some make it to the mining application for starting a mine. A number of projects target iron, gold, base metals, but many of these new discoveries focus on just TTE, such as the REE project I mentioned just before, as well as battery metals. Demand for green power is rising, and also the Northvolt startup in Skellefteå is one example of the industry pushing exploration and development. Many new discoveries of REE are being made, especially in old mining areas like Bergslagen, where they haven't been noticed until now. Reworking of old tailings is evaluated in some cases. And if you have the REE, they can be of quite different origins. You have you'll find them in Kiruna, in Norrbotten, in the very north. There you have it in the apatite iron oxide mineralizations of the Kiruna mine. You can find it in the various skarn deposits in Bergslagen in the south. It's possible to have hydrothermal REE deposits, and also, as the previously mentioned example of the alkaline carbonatite intrusions, such as Norasia complex. So there's many different settings where you can find them. Compared to the rest of the world, the mineral exploration is in a rather small country like Sweden is still notable, and that's quite important. For the present exploration permits, you'll see the green which are applied and red granted. And if you look at the diagram, you show applications for mineral prospecting in Sweden over the last 20 years. And the curve shows significant increase from the financial crisis in 2008. And also, if you compare to the ore prices, there you can see that they also have a big influence on prospecting permits and applications. And as you've seen, there are many known deposits, but Sweden is still very underexplored. There is a high potential to re-evaluate old abandoned mining areas and also to do greenfield exploration. Some of this is done in the metal-enriched organic shales of early Ordovician age. They may be of quite big economic significance. They have historically been used for extraction of potassium aluminum sulfate, called alum, as fuel for lime burning in the old days, quite convenient. You have the lime and the alum shale next to each other, and also lime concretions in the shale. You use it as raw material for petroleum production, distilling oil and petrol from it, long since stopped. There has also been a short period of uranium mining in these shales. Today, the alum shales are exploration targets at several places in Sweden, but with other interests. And we'll have a look at the Scania alum shale in the very south of Sweden, a deposit that is in the prospecting phase. This is a drilling project at the moment, an exploration project on a TCE deposit. Vanadium and battery metals is the target. And in this Ordovician organic shale, which is a part of the Phanerozoic sedimentary covered on the old Phanoscandian crystalline shield. It's a 220 square kilometer prospecting permit. The layers are not very thick. You'll have to have a wide area. Fieldwork and drilling is ongoing. Target of the company is to identify some 1,200 million tons of 0.5 to 0.8% vanadium oxide. So far, they got a York mineral resource estimation of 117 megatons of 0.4 V2O5, indicated and inferred, of which some 62 megatons are indicated and 55 inferred. And they have a lot of work still to do in the license. The mine operation in the area would be subsurface mining. And the problem, as always, public acceptance, fear of the impact. This area, as you see on the image, it's arable land, agricultural use. It's not traditionally mining in this region, so it's you don't have the tradition, you don't have the history. That surely has an influence. And another thing is that that I mentioned before, that this Scandinavian alum shale has high metal content in parts, but generally also a uranium content, which was mined at times. These are low grades, but can of course be extracted and used. It's not technically no problem at all. You need uranium in various civil applications. But in Sweden, we have a political decision to ban uranium mining in Sweden, and this affects usability of many relevant TCE deposits. Of course, this may cause environmental problems and high costs. You must extract the uranium from the tailings. You can't leave it in the tailings. But if extracted, the uranium must, at the moment, be disposed as waste. It's not allowed to be sold. The presentation has now reached the home straight, and I'll summarize Sweden's minerals resources as a kind of SWOT analysis of strength, weaknesses, opportunities, and threats. The Swedish bedrock is variegated and rich on mineral resources. There is the technology and experience to handle it and explore it. We have a strict environmental and health and safety legislation, which is a very, very important thing in mining. Weaknesses are many, though. We experience all time-consuming and costly application processes that tie up financial resources. Unpredictable permitting processes may cause high financial risks for venture capital. And present political ban on uranium might hamper exploitation of the TCE deposits. Sweden's placed 12 on the 2019 Policy Perception Index of Fraser Institute Annual Survey of Mining Companies could certainly improve. Finland and Ireland are good examples. And yesterday, I curiously read the brand new 2020 Fraser Institute survey, where Sweden has dropped to place 20 in the public perception or policy perception index. Still, Sweden is number 2 in Scandinavia after Finland, but the drop is a clear message. Sweden is rich on high critical raw materials, TCEs, REs, battery metals. There is a high potential on new exploration findings. There is a potential to play a strategic role in the EU raw material supply chain. And one might also discuss room for improvement as an opportunity if you concern application, permitting, and policy perception. There we certainly could do better. Threats, as in most countries all over the world, social licensing, geology and mining in public perception. the low public awareness of raw material demands, and also the cumulative effect of the weaknesses. My presentation is now nearly finished. I've talked about the different aspects of the mineral resources of Sweden. We have ancient bedrock. The geological setting differs from most of the EU. The mining sector is diverse. We have many different ores, many types of mineralizations. The industry and mining industry is high tech. We have strong industry clusters behind it. Mineral resources are rich and manifold. They are of significant importance and with high potential for new developments. And for the EU, this is quite strategic. In the future potential, there are unused registered reserves. There are new discoveries being made. There are new places to find mineralizations. We experience a focus change from the traditional metals and mining to the TCEs, REEs, and battery metals. And politics and public perception do play a quite significant role in unleashing these unused potentials. Thank you for your attention.
Thank you, Magnus, for your very interesting and comprehensive presentation on Swedish mining. And now we will have a 10 minutes question and answering session. What can be done about the challenges to profit from Sweden's mineral wealth in the years to come? What do you think?
I think the facilitation of transparent application processes, that's a very important thing. You need to have a predictable outcome, and that would save time and costs for everyone involved, applicant as well as state, as well as citizens. And Sweden is generally, like most other countries, need to work on the public perception. So that's a general challenge, not for Sweden, but for quite many countries that have long times of application.
Okay. So at present, iron is mainly sourced, mined in Lapland, in the northernmost part of Sweden. What can you say about the iron deposits and iron mining possibilities elsewhere in Sweden?
Iron is present at many places and was mined for a very long time in the Bergslagen area of central Sweden. But there are different ore types, different geologic settings. And one thing is that the mines in the north, they have shown to be more competitive with a high grade apatite iron ore of Kiruna, for example. And but due to the world market prices, they are currently discussing reopening some of the southern mines also in the Bergslagen area, such as the Dannemora mine. That's a well-known iron ore mine, which was operating a few years in the 2010s, but then closed again due to the world market prices going down. So the economics rule, and if the prices go up, I will see, or we will see more iron activity also in other parts of Sweden, certainly.
Okay, so I pick up some questions from the Zoom. In what way is environmental and sustainability is captured in the Swedish permitting process for mining?
It is in the legislation, and the companies are keen on working on this, but I think we have to step it up even even more, to just not have the technical aspects of mining, processing, and so you have to have the whole picture, the side rock. What can we do with the side rock? It's not just a side rock as a problem. You have to see it as a potential. What can we do with it? What can we do with the tailings? Do we find other solutions? So we have to work in that way. And partly this is being made, partly we have lessons to learn, so that we really try to use everything that is mined to have it in a better state to avoid any waste. And this is also, I think the legislation is clear, but sometimes also very difficult, because anything that is not a product is by means of the legislation waste. And that is certainly a problem, because then you have very high costs in handling it. But often the problem might be that you can't sell it right away. You could perhaps sell it in 5 years or 10 years or so. You can't get rid of the tonnage of side rock at once. So their legislation have to move a little bit, perhaps, but the companies also have a lot to do.
Are there various scales of mining in Sweden? And if yes, how does the government determine the scale?
I'd say it's not scale in the legal or permitting process, but of course in the impact and social discussions. A big project will have a large impact, of course, much more than a small scale operation. If you think economically, most aim for big projects as you have the better scale of economics, but in the legal sense, it is not a scale involved.
Yeah. So public perception of mining and lack of understanding of the mineral supply chain is a global problem. Are there any good examples of how to combat this from Sweden? Have you managed to go over with these problems?
It's very often the thing of communication. You can communicate anything. You can go out in media and tell things in TV, in the newspapers, social media, whatever. But we all have this bubble of information around this. We hear that what we're used to hear or we want to hear. I think the most important thing would be to reach out, to have personal contact. I mean, talk to the neighbors directly. I have very good experience from that, from my previous job in the limestone industrial minerals industry. That direct contact, direct face-to-face talks are mostly more giving. And then, of course, one thing in this is that we don't have geology at school. We don't know very much about raw materials or what we need. We hear some numbers every now and then in the news, but forget it. A better understanding of the society needs of geoscience and raw materials and geology could be made if you have it stressed a little bit more at school.
Okay, so then a couple of very technical questions. How you are going to extract the vanadium from the alum shale?
I do not have that information, but the Vanadium project website has has a full information on that, and it is an exploration company, and they have, well, it's all there to read. I think the link is in the slide, and you'll be provided from the from EFG with a PDF copy, and there you have the link. You can also just Google on the vanadium Scania project. You'll find it.
Okay. You did mention that the uranium possibly extracted should be stored somewhere. So where are the wastes with uranium stored? Where do they go?
Yeah, that's a good question. The problem is we don't have any active operation in that kind, and of course storing it in the usual tailings, it's not possible. It's not allowed. It wouldn't be allowed. There are of course waste dumps for hazardous materials, and it would have to go at such a place, but it's extremely costly, and if you ask me, a very not a very good solution. Of course, you should use what you mine. It's a thing that I talked about earlier, that you have to use whatever you get up to reduce waste, and there is not this designated solution for taking care of uranium. You have to extract it, but then where to put it? You can't put it back down.
Okay, so the one last question, the short one. What is TCE? What it stands for?
Technology critical elements, such as battery metals, such as the rare earth elements you'll need for creating very strong magnets for the electrical motors you have in all vehicles, and generators and wind turbines and such. Okay.
Thank you, Magnus. I think we have used now the 10 minutes for the question and answering, and I thank you, Magnus, and thank all the participants and listeners, audience, who joined us today, and take care and stay in good health. Goodbye. See you next time.
Goodbye. See you in the next seminar.